Moving on to the ninth sum. A ladder 10 meter long reaches a window 8 meters above the ground. Find the distance of foot of ladder from base of the wall. Now moving on to solution. He says that a ladder 10 meters reaches the window 8 meters above the ground. So let us assume that ground, and here it's window A, 8 meters from the ground level, and the length of the ladder B, AB, which is nothing but 10 centimeters. Here the contact of wall with the ground be C. Then here the foot of ladder from base wall is BC. So let us assume it as A. This just look like right angle triangle ACB is formed with hypotenuse as 10 meters and other two sides as 8 meters and A meters. We know that from Pythagoras theorem. Hypotenuse square is equal to sum of squares of other two sides. We can say hypotenuse square, that is AB square, is equal to sum of squares of other two sides, that is BC square plus AC square. That implies AB square here we have as 10 square, which is equal to BC square, that is A square, plus AC square is given as 8 square. That implies A square is equal to 10 square is nothing but 100 minus 8 square is nothing but 64, which is equal to 100 minus 64 is nothing but 36. That implies as A square is equal to 36, A will be equal to square root of 36, that is nothing but 6. Therefore, we got A is equal to 6 meters. Therefore, distance of foot of ladder from wall is 6 meters. Moving on to the 10th question. A guy, wire attached to a vertical pole of height 18 meters is 24 meters long and has a stake attached to the other end. How far from the base of the pole should the stake be driven so that wire will be taut? Now moving on to the solution. He says that there is a vertical pole of height 18 meters from the ground and a wire is attached of length 24 meters to which stake is attached to the other end of the ground. So let the point where stake attached be A and the point of contact of vertical pole with the ground be B, and height of the vertical pole at the top be C. Then here ABC is a right angle triangle. So he asked us how far from the base of the pole should the stake be driven so that wire will be taut. So we need to find the length of AB here. So let it be as A meters. Then from Pythagoras theorem we can say that in right angle triangle hypotenuse square, here which is nothing but AC square, is equal to sum of square of other two sides, that is AB square plus BC square, which implies here AC square is 24 square is equal to AB square is nothing but A square plus BC square is 18 square. That implies A square is equal to 24 square is 576 minus 18 square is 324. Finally we get A square is equal to 252. So which implies a square is equal to 252 can be written as 6 into 7. That implies a is equal to square root of 6 into 7, which is equal to 6 root 7. So finally we got a is equal to 6 root 7 meters. So the distance of stake from the base to taut the wire is 6 root 7 meters. Now moving on to 11th sum. An aeroplane leaves an airport and flies due north at a speed of 1000 km per hour. At the same time, another aeroplane leaves the same airport and flies due west at a speed of 1200 km per hour. Find how far apart will be the two planes after 1.5 hours. Now moving on to the solution. Let us note down the directions, that is north, south, west, east. He says that first aeroplane has flight due north. So from common point O, let us assume that aeroplane A has flight to certain distance in 1.5 hours with a speed of 1000 km per hour. Now he again says that another aeroplane leaves the same airport, that is point O, and flies due west at a speed of 12 km per hour. So after 1.5 hours, let us assume that aeroplane, that is second aeroplane, is at D. Now he asked what is the distance between first and second aeroplane, that is AB. We know that north direction is perpendicular to west direction, we can say OA is perpendicular to OB. So now moving on to solution. Speed of first aeroplane 1000 km per hour. So now distance travelled by first aeroplane in 1.5 hour will be OA, that is equal to 1000 into 1.5 hour is nothing but 3/2, which is equal to 2 goes in 1500 times, and 500 times 3 is 1500 kilometers. So we got OA as 1500 kilometers. Now similarly, the speed of second aeroplane is 1200 km per hour, and let us calculate the distance travelled by second aeroplane in 1.5 hour, which is equal to 3/2 times 1200 km per hour, that will be equal to 2 goes in 1200 600 times, we get 1800 kilometers. So we got OB is equal to 1800 kilometers. From Pythagoras theorem, we can say that in right angle triangle, hypotenuse square is equal to sum of squares of other two sides. Here AB square will be equal to OA square plus OB square, which implies AB square is equal to OA, which is nothing but 1500 square plus OB, nothing but 1800 square, that is equal to 1500 square is nothing but 22,500. 1500 square is nothing but 22,50,000 plus 1800 square is nothing but 32 lakh 40,000. So overall we get 54 lakh 90,000. Now finding the value of AB, we get root of 549 into 100. So that is nothing but 100 root 549. On further simplification we get 100 into, if we take 9 common here, 9 into 61, that is equal to 300 root 61. Therefore the distance between aeroplanes after 1.5 hours will be 300 root 61 meters. Moving on to the 12th question. Two poles of heights 6 meters and 11 meters stand on a plain ground. If distance between the feet of poles is 12 meters, find the distance between their tops. Now moving on to the solution. He has given that two poles of height 6 meters and 11 meters, which are 12 meters distance apart, lie on the ground, and he asked us to find the distance between tops. Let us assume that AB be the first pole and CD be the second pole and BD be the distance between the poles. Then he asked us to find the value of AC, that is distance between the tops. In order to find this, let us draw a line joining A to CD, that is AE, such that AEBD forms a rectangle. AB is equal to 6 meters, CD is equal to 11 meters. Then we get CE or EC is equal to CD minus ED, which is equal to CD minus ED is nothing but AB, as it is a rectangle, that is equal to CD is nothing but 11 meters minus AB is nothing but 6 meters. So finally we get CE is equal to 5 meters, and also we get AE is equal to BD, as in rectangle the lengths will be equal, which is nothing but 12 meters. So here we also got AE. We know that AEC is a right angle triangle. Therefore, by applying the Pythagoras theorem in right triangle AEC, we get the hypotenuse square, which is nothing but AC square, is equal to sum of square of other two sides, that is AE square plus EC square. That implies AC square we need to find, which is equal to AE square, that is 12 square, plus EC square or CE square is same, so that is 5 square. That implies AC square is equal to 12 square is 144 plus 5 square is 25. That implies AC square is equal to 144 plus 25 is 169. That implies AC is equal to square root of 169, that is 13. Therefore, distance between the tops of poles here is 13 meters. Moving on to question number 13. D and E are points on sides CA and CB respectively of triangle ABC, right angle at C. Prove that AE square plus BD square is equal to AB square plus DE square. Now moving on to the solution. Let us consider a right angle triangle. ABC, which is right angle at C. Here he says that D is a point on CA and E is a point on CB. And finally he asked us to prove that AE square plus BD square is equal to AB square plus DE square. Now in order to do this, let us join AE, then we get triangle ACE as right angle triangle. Now in right angle triangle we know that hypotenuse square is equal to sum of square of other two sides. We can write AE square is equal to AC square plus CE square. Let it be as equation number 1. Now again let us join BD. Then we get triangle DCB as right angle triangle, and here hypotenuse square, that is BD square, is equal to BC square plus CD square. Let it be as equation number 2. Now let us join DE, then triangle CED will be also right angle triangle. In this also let us apply the Pythagoras theorem. Then we get hypotenuse square, that is DE square, is equal to CE square plus CD square. Let it be as equation number 3. Now let us add both the equations 1 and 2. Then we get AE square plus BD square is equal to AC square plus CE square plus BC square plus CD square, which is equal to AC square plus BC square. Let us write it together, plus CE square and CD square. Let us write it together. Now if we consider triangle ACB, it is also a right angle triangle. Therefore by applying the Pythagoras theorem we get AC square plus BC square is equal to hypotenuse square, that is AB square, which is equal to, we know that AC square plus BC square is equal to AB square plus CE square plus CD square is equal to DE square from equation number 3. Finally we can say that AE square plus BD square is equal to AB square plus DE square. This is what the proof required for us. Moving on to the 14th question. The perpendicular from A on side BC of a triangle ABC intersects BC at D such that DB is equal to 3 times CD. Prove that 2 times AB square is equal to 2AC square plus BC square. Now moving on to the solution. He has given that AD is perpendicular to BC and DB is equal to 3 times CD. We know that here base BC is consisting of CD and BD. We can say BC is equal to CD plus DB, which implies BC is equal to CD plus DB can be written as 3CD, which implies BC is equal to 4 times CD, that is nothing but CD is equal to 1/4 times BC. let it be as equation number 1, and as CD is equal to 1/4 times of BC, we get DB is equal to 3/4 times BC, which is, let it be as second equation. Now in triangle ACD, let us apply the Pythagoras theorem as angle ADC is equal to 90 degrees. That is, hypotenuse square is equal to sum of square of other two sides, that is CD square plus AD square. Also, if we consider in triangle ADB, it is also a right angle triangle as ADB is equal to 90 degrees. Square of hypotenuse, that is AB square, is equal to sum of square of other two sides, that is DB square plus AD square. So here we need to eliminate AD square. So let us subtract both the equations, then we get AC square minus AB square is equal to AD square will be cancelled, and we are left out with CD square minus DB square. This is in the form of A square minus B square, which can be written as A plus B into A minus B. That implies CD plus DB is nothing but BC into CD minus DB is nothing but 3 times CD. Then we get minus 2 times BC into CD. So now, in order to change the sign of right hand side, let us multiply it with minus. Then we get the equation as AB square minus AC square is equal to 2 times BC, and we can write that CD is equal to 1/4 times BC from equation 1. So finally we got that AB square minus AC square is equal to BC square by 2. Now by cross multiplication we get 2 times AB square minus 2 times AC square is equal to BC square, which implies 2 times AB square is equal to BC square plus 2 times AC square. This is what the required proof for us.